So let's continue doing the practice test. So problem number 16, we have twice what number yields in 8 and 2/3. So whenever they say twice what number, our vocabulary says that we must use twice what number stands for the box. So box is going to be here equal to 8 and 2/3. Twice what number yields 8 and 2/3. So what are we missing here? We're missing one of the multipliers. If we're missing a multiplier, we must divide the product. The product 8 and 2/3 divided by 2. Let's check if each of them is a fraction. This is not a fraction, so I have to convert this into a fraction, which is going to be 26 over 3 divided by 2 over 1. So now once they're a fraction each of them, I have to change this division into a multiplication statement. So 26 over 3 times 1/2. So let's break each of them as a product of prime number. 26, what times what give me 26? 26 can be written as 2 times 13. So instead of writing that 26, I'm going to have to write 2 times 13. So I'll have 2 times 13 over 3 times 1/2. Let's see what we can cancel here. I can cancel a 2 here, and that's the only thing I can cancel. So I will try to multiply. 13 times 1 gives me 13, and 3 times 1 gives you 3. That's your final solution. Or if you decided to change it into a mixed numeral, we will have, what would that be? 4 times 4 and 1/3. Let's keep doing this translation problem. Recall that for 16, this will be solution A, and this will be our solution B. You are required to give the equation and then solve that equation. Let's do problem 17, in which in 17, you have to do more of this translation. So problem 17. Problem 17, they want us to translate 210, well, it's 210, is, and recall that in our vocabulary, is stands for equal. 7/12, that's a fraction, 7/12 of, the word of stands for multiplication, so we have to multiply, and what number stands for our box. So, what are we missing here? We're missing one of the multipliers. So if we're missing one of the multipliers, we must divide. What are we going to divide? The product 210 divided by the known multiplier, in this case, 7/12. But this is not a fraction, so I need to make it a fraction. So I'll put a 1 underneath, and now that's a fraction. I need to change that division statement into a multiplication statement. And to do that, we must switch the fraction. So it will be 12 over 7. Or multiply times its reciprocal. Now let's factor each of them. So 210. What is what give me 210? Let's see. Well, this ends in 10, so if it ends in 10, that should be 21 times 10. And this 21 should be 7 times 3. And this 10 here should be 2 times 5. So now I have the 12. So 12 should be 4 times 3. And this 4 is going to be 2 times 2. And this should be a 3. So the 7 is a prime number, so I'm not going to do anything with it. So 210, I'm going to write it as a 7 times 3 times 2 times 5 over 1. So instead of writing that 12, I'm going to have a 2 times 2 times 3 over 7 And let's see what we can cancel here. I have a 7 that can cancel out. I have another 7 that I can cancel out. So now we're only left with this, which is 3 times 2 is 6 times by 5 is at 30. You have a 30, and this was part of the 12. Well, we pretty much have 30 times 12. Let's do that on the side. What is 30 times 12? Or 12 times 30. That will give us 0, 6, 300. So that will be 360 as the final answer. In your test, you are required to read the equation and to solve that equation. Problem 18. 120 is what fraction of 220? Let's solve that. So once again, recall that E stands for equal and off stands for multiplication. And what number is going to be our box? So 120, so I'm just going to write down 120 is equal what fraction, so box, of 220. So what are we missing here? We're missing one of the multipliers, therefore we must divide. We're going to have to divide the product, in this case that is 120, divided by the known multiplier, 220. Now, this could be two fractions, or remember that a fraction is divided by, I could write 100 over 120 over 220. Or you could have done times 1 over 220, and we'll leave it to that. So, but the good procedure will be, well, 120 divided by 220, since those two are whole numbers, I can just put it into a fraction mode, because this part means divided by. So, the technique here is, if it ends in 0, we're going to have to cancel a 0. So, what else? Well, we have to factor each of them. So 12, what times what gives me 12? 12 can be a 6 times 2, and this 6 can be a 3 times 2, and bring these 2 down. Now the 22. 2 times 11. Therefore, instead of writing that 12, I'm going to have to write a 3 times 2 times 2 over 2 times 11. So now let's cancel one of these out. It's a pair of 2s. Now that's it. That's all I'm left with. So 3 times 2 is 6. Will be 6 over 11. And that will be it. Now let's do problem 20. Problem 19. The previous one was problem 18, so this is 19. A rectangular jar is 10.5 feet long and 8 4/7 feet wide. What is the area of a jar? So whenever you're given an area problem, first picture your rectangle here. So that's a rectangle here. Now, they say that this part here, this is 10 1/2 feet. Yes, 10.5 feet long. And the width is 8 4/7 feet long. They're asking you to find the area. So the space between this. They're asking you to find this part here. What is in between here. So how do we find the area of a rectangle? We must recall our formula, which the formula says area is equal to length times the width. So to find the area, we must know the length and its width. Do we have those given information? Yes. 10.5 is the length and 8 4/7 is the width. Therefore, to find the area, let's just multiply these two. The area we don't know in this case is a box. The length should be 10.5 times the width, which is 8 4/7. We're missing the product, therefore we just multiply this multiplier. So 10.5, this must be a fraction. So since this is not a fraction, let's convert each of them into a fraction. 2 times 10 is 20, plus 1 is 21. So that will be 21 over 2 times 7 times 8 should be 56, plus 4 should be 60. So that will be 60 over 7. Now let's write each of them as a product of prime numbers. So 21, what times what give me 21? 21 could be a 7 times 3. 60, what times what could give me 60? 6 times 10, and 6 should be a 3 times 2, and this 10 should be a 2 times 5. Let's rewrite it. 21 is a 7 times 3 over 2, and this 60 is going to be 3 times 2 times 2 times 5 over 7. Let's see what we can cancel out here. Look, there's a pair of 7 here, so I can cancel them out. What else? There's a pair of 2 there, so I'll cancel these 2 out. Is there anything else that we can cancel out? No, everything in the denominator is gone. So let's just multiply it straight across. 3 times 3 is 9, times 2 is 18, times 5 is 18 times 5. Well, I cannot do that in my head, so 18 times 5 should be 5 times 8 is 40, 5 times 1 is 5, plus 4 is 9, so that should be 90. 90 over 1, which should be 90. Well, so that's my final answer. That should be 90. No. In your test, you're going to be required to give the number and its units. And what are they asking you for? They're asking you for the area. And recall that area, the units of an area, always start with a square. So this is going to be a square. But square what? Square feet. So that will be 90 square feet. That should be your final answer for problem 19. You're going to be required to give the numeric answer and its unit. If you only give 90, then you will have the wrong answer. We will not give you full credit for that. So make sure you put 90 square feet. Now, problem 20. Problem 20 tells you a rectangular floor contains 200 square feet. And the length of the floor is 16 and 2/3. Find the width. So, in any problem that you're given for finding the area or something that relates to the area, we're going to need this formula here. Area is equal to length times width. So it's very good that you memorize that formula. And we're always going to have to draw our little rectangle here to have an idea what is given and what is not given. Let's read the problem again. They're telling you in problem 20, in this case is problem 20, they say the rectangular floor contains 200 feet. So they're telling that the area inside here is 200 square feet. So they're giving you the area. They're also giving you the length of the floor is 16 and 2/3 feet long. They don't give you the width. They say find the width of the floor. So they don't give you this part here. Now let's fill our formula here. The area in this case was given is 200 equal the length is also given, which is 16 over 2/3 times the width. We're not given the width, so we just have to write a box for that. Now what are we missing here? We're missing one of the multipliers, therefore we must divide. Divide what? The product, in this case, which is the 200. So it's going to be 200 divided by 16 and 2/3. Now, what are we going to do as a next step? Got to make sure that these two are a fraction. This 200 is not a fraction. To make it a fraction, we'll have to put a 1 underneath. Now, this is a fraction, but this is not a fraction. Therefore, let's convert that into a mixed numeral. So I will have 200 over 1 times, divided by, let's convert. 3 times 16 if you do your math, that will be 48 plus 2 will be 50 over 3. Now, let's change that division into a multiplication statement. So it'll be 200 over 1 times 3 over 50. One really good trick about here is that if it ends in 0, you can just cross the zeros out because there are multiple of them. Now, in other words, you have to factor 20, 3, and 5. These are prime numbers, so you don't have to work that. But this 20 can be what? This 20 can be a 4 times 5. And then this 4 can be a 2 times 2. And bring the 5 down. Therefore, instead of writing 20, what we're going to have to write is 2 times 2 times 5. Now, 2 times 2 times 5 over 1 times 3 over 5. What can we cancel out here? I have a pair of 5, so I think that's what we can cancel out. What else? There's nothing else to cancel out. Therefore, our answer should be 2 times 2 times 3, which is going to give us, well, 2 times 2 is 4, times 3 is 12 over 1. But 12 over 1 is actually 12. So our final answer should be 12. But be careful, in this type of problems, when it involves area, they always ask you to give you the units. However, what are they asking you for? Asking you for how long is the width. So they're not asking you for area. So if you put here a square feet, that will be wrong. Because in other words, you're giving the area, but the area is 200 square feet. Therefore, we might just say, well, how long is it? How big it is? It's 12 feet long. When you say 12 feet, that will be your final answer. 12 feet. All right, let's do problem 21, which probably involves rate. Let's see what do we have for problem 21. Once again, a quick reminder, when you are doing an area problem, draw your picture for a rectangle, fill out the given information, recall the formula of area is equals to length times width, because that will be very essential to get those answers correct. So, problem 21. Problem 21 says, for a party, Karina wants 60 servings of punch that each contain 5 1/4 ounces. How much punch does she need? So let's recall this formula that says the total quantity, or no, it says the size, it says the number of parts or people or servings times the size of each part or each people, whatever you're trying to share or cut, is equal to the total quantity. So this formula will be very important. Whenever you see the word each in a word problem, it means that you have to use that formula. Number of parts, people, or servings times the size of each part should equal to the total quantity. Quantity, yes, quantity, yeah. So the total quantity, the total amount. So in this case, it says for the party, she wants 60 servings of punch. So that's the amount of servings, the number of servings. She wants 60 of them times the size of each. Say that each contains, so they're giving you the size of each, which is 5 1/4 of an ounce, equal to the total quantity. Say, how much money does she need? So, how much? The total of it. So that's your box here. Therefore, this turns out to be something that we work on 4.3, which is find the missing number. We're missing the product, therefore we must multiply. What are we going to multiply? Well, these two multipliers, 60 times 5 1/4. But this is not a fraction. To make it a fraction, you put a 1 underneath, and to make this a fraction, you have to convert that into improper fraction. 4 times 5 is 20, plus 1 is 21 over 4. Excellent. Now let's break each of them as product of prime numbers. 60. Let's do that on the side. 60. What times what gives me 60? Well, that's a 6 times 10. And that 60 is a 2 times 3. And that 10 is a 2 times 5. 21. What is what gives me 21? Let's see. 21 is a 3 times 7. And that 4 that we have there is going to be what? 2 times 2. Now we have each of them factored. Now let's write 60 is 2 times 3 times 2 times 5 over 1 times 3 times 7, and that 4 is a 2 times 2. Let's see what we can cancel here. I have a pair here. I have another one here. The 2's. What are we left with? 3 times 5 times 3 times 21. Well, 3 times 5 is 15, and then we have a 15 times 21. Let's do that on the side because I cannot do it mentally. So 15 times 21, 1 times any number is the same, so that will be 15. 2 times 5 is 10, carry 1. 2 times 1 is 2, plus 1 is 3. Therefore, we're left with 315. So our final answer is going to be 315 over 1, which is 315. Now, 315 what? What are they asking you for once again? They're asking you for the total quantity. And we're talking about, well, am I going to have 315 servings? No. We're going to have 315 ounces because that's the total ounces of punch that you want to share. 315 ounces of punch. So, anytime that you see the word each in a word problem, means that you're going to have to use this formula. Okay? So, we will do problem 22, which apparently has an each. So, I'm not going to erase this formula because it's very essential whenever we have that each word in our word problem. So, if you locate the word area, it means you're working with the rectangle, that you have to draw your rectangle, have your formula for the area, and if you're seeing the word each, it means that you're working with this type of formula. So let's do problem 22 now. Problem 22 says, a chef prepares 30 cups of rice. Well, that 30 cups of rice could be a total quantity or the number of parts. Let's keep reading. Each serving of rice is 2 3/3 of a cup. So it's 2/3 of a cup. Oh, they're telling you the size of it. The total quantity may be the 30 cups, but let's keep reading. How many servings can he make? So they're asking for the number of servings. Oh, so these should be the number of servings should go there. And the total quantity, well, he has a total of 30 cups of rice. So what are we going to do here? What operation are we going to have to do? Well, if we follow this formula, this tells you that we're missing one of the multipliers. If you're missing one of the multipliers, what you should do? We must divide. What are we going to divide? The product divided by the known multiplier. So it's going to be 30 divided by 2/3. Now, well, how am I going to do this? Well, these of these are they need to be a fraction. I'll put a 1 underneath, and I got to change the division statement into a multiplication statement. So 3 over 2. Now, what else? Well, as we followed before, got to factor each of them. Got to factor the 30. What is what will give me 30? Let's see on the side. Well, it ends in 0, so it should be a 3 times 10. And this 3 is, bring it down, and this 10 is a 2 times 5. Therefore, instead of writing that 30, I'll probably want to work here. Instead of writing this 30, we're going to have to do 3 times 2 times 5 over 1 times 3 over 2. Well, those are prime numbers. Let's see what we can cancel here. Only a pair of 2's. That's it. We can cancel anything else. So let's just try to multiply it. So 3 times 5 is 15, times 3 is going to be 40, 5. But 45 what? That will be the number of parts. So how many servings can we do? Is 45 servings. So you see the word each in a problem means that you have to use that formula. Now, what's 23? Let me skim through it. It's a committee that has 40 members, 58 of the members are women. So you don't see the word each in this problem. So therefore, we're not going to use this formula anymore. So let me erase that. So whenever you see the word of something, or 3/4 of something, or this of 2/3 of the population, 1/6 of the student workers, or anything related with of something, that tends to be a translation. But let's keep reading this again. A committee has 40 members. So, okay, maybe I'm going to use that data. So I'm going to analyze my data and I say, well, the total committee members, the total members of the committee is, I'm just going to put, is 40 so, of the committee. Okay, 5/8 of the members are men. Oh, and then they say how many men are on the committee. So, but they give me a relation between the men and the total members. They say that 5/8 of the members, meaning the total, are men. So we have to use a translation word because we saw that all of the members are. We know 5/8 is just 5/8. All of it stands for multiplication. The members. What is the total members that we have? Oh, that was the 40. That was given in the first sentence. The R. What does the R stand for? Stands for equal, sign, equal. And the men, do we know the men? No, we don't know how many men there are. So that's a box there. So in other words, we're mixing the product. We must multiply. 5/8 times 40. Yeah, times 40. So put over 1. Now, I gotta break everything as a product of prime numbers. Let's see. What is 40? 40 can be a 4 times 10. And this 4 can be a 2 times 2. And this 10 can be a 2 times 5. And that 8 is going to be a 4 times 2. And this 4 is going to be a 2 times 2 times 2. What else do I need to break down? Anything else? No, because the 5 is a prime number. Let me write that here. 5 over 2 times 2 times 2. The 4 is going to be, what is it? 2 times 2 times 5. 2 times 2 times 2 times 5 over 1. Now let's see what we can cancel out here. A pair of 2 here. Another 1 here. Yes. Excellent. And what else? Here, correct? Yes. Can I cancel these 5? No, because they are both in the numerator. It has to be one in the numerator and one in the denominator. So let's just straight multiply once everything is canceled. So 5 times 5 is 25. 1 times 1 is 1, so it's just going to be 25 over 1. So 25 over 1 is just 25. So my answer is 25. But 25 what? What was the question? How many men there are? So there are 25 men in the committee. Alright, so this turned out to be a translation problem, and whenever you have a translation problem, you usually see a number or a fraction of something. So a fraction of something. So what fraction of this are men? Or 5/8 of the members are men. So in those type of phrases, you're going to see a translation problem in which we have to use our vocabulary. Over stands for times, and equal stands for are or gills or is. For example, problem 24, I mean 23. This was problem 23, sorry, this is problem 23. So we have to do now 24. 24 is going to be 2 nights of the students in Gloria's class work full time. So once again, we're seeing the relation of a fraction of. So whenever you see a fraction of or Well, they're giving you 2/9 of the students in lower class work full time. They're giving you a translation problem. Okay? So let's do that. You say 2/9 of the students in Gloria's class work full time. 18 students work full time. How many students are in Gloria's class? Okay, 2/9 of the students in Gloria's class work full time. So pretty much, let's write 2/9. 2/9 of the students, meaning the total students in Gloria's class, right? The students in Gloria's class work or are the ones that work full time. So let's translate this. 2/9 of the sums for multiplication. The students in Gloria's class. Do we know how many students are in Gloria's class? No. That's what they're asking you for. Say, how many students are in Gloria's? So we don't know how many students are in Gloria's class. So work, well actually when they say work full time, they're telling you are the ones that are working full time. So you should have an equal there for work. Full time. Do we know how many students work full time? Yes, it's given. And they say that 18 of them work full time. So that 18 should go there. Now what are we missing here? We're missing one of the multipliers. Therefore we must divide 18 divided by the non-multiplier. So 18 is a product divided by 2/9. This gotta be a fraction. This is not a fraction. Therefore, I must put a 1 underneath. So 18 over 1 divided by 2/9. What else can we do here? Well, I have to change that into a a multiplication statement. So that will be 18 over 1 times 9 over 2. 18. What is what gives me 18? Well, 18 can be a 9 times 2, and this 9 can be a 3 times 3, and bring the 2 down. So therefore, instead of writing 18, I'm going to have to write 3 times 2. Instead of writing 9, I'm going to have to write what? 9 is at 3 times 3. Let's rewrite those things. So 18 is going to be 3 times 3 times 2 over 1, and that 9 is going to be a 3 times 3 over 2. Let's see, what can we cancel out here? I have a 2 and a 2 that I can cancel. What about these 3? Can I cancel these 3's? No, I cannot cancel 3. Why? Because they're both in the numerator. Now, there is nothing else to cancel, so I might just straight multiply. 3 times 3 is 9. Since this is 9, and I have another 9 here because 3 times 3, so that will be 9 times 9 is 81. So it will be 81 over 1, and 81 over 1 is actually 81. But 81 what? What are they asking you for? So that's how we'll find an answer, but this is a word problem. Let's answer it in words. You say, how many students are in Gloria's class? So there will be a total of 81 students. That should be your final answer. Just be aware of the units there. In some question in the test, they ask you to include your units. Pretty much, usually on the rectangle, but not here. So it will be 81 students. Just make sure that your answer makes sense with the question. Say, how many students are in Gloria's class? There are 81 students. Now it says, now let's read the next problem. Maybe we're going to be using translation again. But it says, Angela gets paid $20 an hour. How much does she get paid if she works 2 hours and 1/6 of hours? So that appears to be a rate problem. Why? Because you're comparing two quantities. They say that she makes $20 an hour or $20 per hour. Right? So whenever we're using a rate problem, you have to identify the rate and write the structure, as done before in the custom enhancement. In the custom enhancement, you were required to write the structure of an equation involving rates. because that rate can be reading as a multiplier. Therefore, let's see, if I'm going to do dollars per hour, if I'm going to have to do dollars per hour, in the customer enhancement say, you have to multiply from some type of units to get some type of units. Now, how would I find those units? We will have to use the rainbow method. So this hour with this hour should match here. So I'll put hour times hour here. And this dollar is going to go all the way here to the dollar sign. So with that, you came out with an equation. That's what it's called the rainbow method. That's sort of my type of rainbow. So dollars per hour times hour should give you dollar. So you have your structure there. So if you have that structure, you got the problem. You can have the answer 100% correct. So let's read the problem. Say $20 an hour. So $20 an hour, that's actually a rate. That's 20 times, what does it say here? It say, do we tell us how many hours? Let's say, it says 2 1/6 of an hour equals $1. Do we know that? No, she says, how much does she get? How much does she get paid? So we don't know how much money she's making, so that should be your bucks. So look, if you have the rate structure, you can have the answer by plugging it back. The rate is given, so 20 times the hours equals $1, and you have your answer. So let's multiply. 20 times 2/6, because we're just missing the product, multiply them. Like, it has to be a fraction, so it's 20/1 times this guy here. 6 times 2 is 12, plus 1 is 13, so that will be 13/6. What else? They have to be reading as a product of prime numbers. You know the word factoring them. 20. Let's factor the 20. We done it previously, but let's keep doing this. 20 is a 4 times 5, and this 4 is a 3 times 2. And bring the 5 down. 13 is a prime number. 6. 6 is a 2 times 3. Now 20 is going to be 2 times 2 times 5. 2 times 2 times 5 over 1 times 13 is going to be, well, 13 is a prime number. 6 is going to be 2 times 3. Therefore, let's see what we can cancel out. 2 and 2 go. It's gone here. Now what else? There's nothing else. Be aware of this. Sometimes we tend to cancel the 3's, but that 3 is part of a 13. It's not a factor. So where we left with is 2 times 5 is 10. 10 times 13 is 130 over 3. So that's how much money she makes. Now, yes, that's the correct answer. However, you can try to give it as a mixed numeral, but you don't need to. But you want to have an approximate what is that, you can do your long division. But if you leave it like this in the test, it's still correct. So she makes 130 over $3. You can say that, it's still fine, because this is reduced to the lowest terms. Now, you can convert that into a mixed numeral. Let's do that, just so you get an approximation what that is. 130 divided by 3. 3 goes into 13 how many times? 4. Excellent. 4 times 3 is 12. Subtract that. 1. Bring the 0 down here. This 3 goes into 10 how many times? 3. Excellent. 3 times 3 is 9. 10 minus 9 is 1. Therefore, we're left with 43 holes and 1/3. So how am I going to know the structure? Why not 3 holes in 43 over 1? Well, the technique of the clockwise method, you go like this. Look at the clock. 43 holes, I'll go right here, or 43 holes and 1/3. So that's how much money she makes for working almost 2 hours in one day. It makes sense, because 20 times 2 is about $40 and 1/6 of an hour. She's about making $3 and 1/3. So our answer is correct. Okay, so whenever you're given the rate problem, you will identify by the word per, or in this case was dollars an hour, which you can say dollars per hour, and just write your structure. You have it. You have all your problems. Once you, if this was miles per hour, they multiply times hours to get miles. Okay, you just need a little bit more review how to do this how to do this rate structure, you can go to Custom Enhancement Chapter 4, and you will see those type of problem exercises. And you can get a little bit more of examples in those structures. So let's do problem 25. Well, this was problem 25. Sorry, this was problem 25. So problem 26. Now we want to do problem 26. A sprinter runs 1/4 of a mile per minute. So it's telling you a rate there. So in other words, we're going to have to use the structure again. We got to do an instruction for our rate. You say miles per minute? Yes. So since you have a rate, the first step you're going to do is just write your rate. So I'm going to erase this part here from the rainbow method, because that will help you to get the rate. So it says mile per minute, or miles per minute, it's up to you. So we write miles per minute. Well, we must multiply it in some minutes to get miles. So, what is the rate? Let's say a sprint runs 1/4 of a mile per minute. How long does it take to run 201/8 of a mile? So let's see what are we given again. We're given the rate. The rate is 1/4 times how long. They say how long, so they're asking you for how many minutes does he take, or say he or she. Problem 25. We're given miles per minute times minute equals mile as a rainbow method, as we explained it, because it tells you how long does it take. So it'll be how long does it take, how many minutes does it take. They give you 201/8 of a mile, and they give you the rate 1/4. Therefore, let's see, what are we missing here? We're missing a multiplier. Therefore, you must divide 201/8 divided by 1/4. So let's convert this each into a fraction. 8 times 2 is 16, plus 1 is 17, so 17/8 divided by 1/4. Now let's change that division into a multiplication. So it's 17/8 times 4/1. Now for us to be able to do that, I must factor each of them. So 17 is a prime number, but 8 is not. So 8 can be written as 4 times 2, and this 4 can be written as 2 times 2. And carry that 2 down. That 4 here that we had itself should be a 2 times 2. And let's rewrite what we have here. So 17/2 times 2 times 2 times 2 times 2 over 1. So the 8 is here and the 4 is here. Now, let's see what we can cancel out. I have a 2 here that we can cancel out. I have another 2 that I can cancel out here. So what are we left with? 17/2. And as I said before, this is your final answer. How long does it take? 17 half minutes. Or if you want to do the long division, you want to see how many minutes is that about? That should be, after you do your long division, that should go 8.5 minutes. So both of them are your correct answer. But if you finish up to here and you can see that this is reduced to a lowest terms, then this is a fine answer as well. That will be it for problem 25. I mean, that was problem 26. Keep getting used to those numbers. So that's 26. All right. And lastly, we will do problem 27. That is going to be a rectangle. So they're giving you a rectangle is 5 1/4 miles. So you have to find the ratio of it. So whenever you're given a rectangle, you must draw the rectangle. So let's write our rectangle. So problem 27. The rectangle is 5 1/4 meters long. So let me just write our rectangle. Its long is 5 1/4. I say meters. And the width is 4.5 meters. Find the ratio of the width to the length. The ratio of, we call the word ratio of. the ratio of the width to the length. So this is not an area problem. This is a ratio problem, width to the length. So whenever they ask you to find the ratio, it's a division problem. So instead of these two, it's going to replace it by a divided by symbol. So if they're asking the ratio of the width to the length, you just have to divide the width divided by the length. In this case, my width is 4.5 meters, so it will be 4 1/2 divided by 5 1/4. That's all we need to do here. So once you divide that, you will find your ratio. So let's convert each of them into improper fractions. 2 times 4 is 8, plus 1 will be 9, 9.5 divided by 4 times 5 is 20, plus 1 is 21, 21 over 4. Let's convert that division into a multiplication statement. So that will be 2 over 9 over 2 times 4 over 21. Let's factor each of them. So instead of writing that 9, I'm probably going to have to write 3 times 3. Instead of writing that 4, that will be a 2 times 2. And instead of writing that 21, it should be a 3 times 7. Now let's rewrite everything here. So that will be, instead of the 9, it will be a 3 times 3. Instead of that 2, well, the 2 was a prime number, so it should be 2. The 4 is a 2 times 2. And the 21 is a 2. That's a 3 times 7. Now, what can we cancel out there? Let's see. I have a pair of 3's here. What else? The 2's? Yes, the 2's. There it is, the 2's. Now, what are we left with? Well, there's nothing else to multiply. So, to cancel. So just straight multiply. 3 times 2 is 6. 6 over 1 times 7 is 7. So that will be your ratio. 6 7. And the ratio does not have a unit. So the ratio should be 6 7. So that will be it for practice test. If you still need more practice on the practice test, I would recommend you to do all over again on your own and see how many are you missing. And for example, this practice test for me has 27 questions. If you only have 4 errors or 5 errors on this test, that means that you have high chances of passing the class. Passing the course, this chapter, and so do it again. And if you sort of feel like you had more than the half wrong, then only focus on the ones that you had wrong. So if you had those wrong, redo them, look back into the chapter, or ask in the front desk if you need an extra review sheet in that certain type of problem. Okay, and do your best on the test, and I'm sure you guys will get it. Thank you.